Here we are given a big log of wood of size m cross n. We need to cut this big log of wood into smaller pieces and we need to sell them in the market. We're also given a prices array wherein each element of the array has three attributes: the size, the height of the log, the width of the log, and the price for the log. If we have a log of given height and width, its price would be pi. What do we need to do? We need to return the maximum money that can be earned after cutting the log of size m cross n, dividing into smaller pieces and then selling it into the market. So here they have provided us with an example. I'll be walking you through this example as well as the algorithm to go about it. Why the presentation? So let's quickly hop onto it. Leetcode 2312, selling pieces of woods. It's a hard level question on Leetcode, but I don't feel the same. The concept that we will use to solve this question would be dynamic programming, and you will yourself see towards the end of the video that it's not that complicated. It's really simple. Also, in case if you have any doubt understanding this question, or if you want to ask anything from me in general, please don't forget to drop a message on the Telegram group or the Discord server of Coding Decoded. Both the links are specified below. So let's take the same example that was specified in the question. We are given a big log of wood of size m equals to 3, n equals to 5. So this is 3 into 5 dimensions of the log of the wood that is given to us. The prices of 3 log of woods are stated. The first one is 1 into 4. The price is 2 units. So 1 into 4. For the log of wood of dimension 1 into 4, the price is 2 units. For the dimension 2 into 2, the price is 7 units, which is this one. For the log of wood of dimension 2 into 1, so 2 into 1, the price is 3 units. So in order to cut this entire big log of wood of dimension 3 into 5, what is the maximum money that can be generated out of it? So the maximum money output happens to be 19. And how 19? Let's try to analyze it. So we will be creating two log of woods of dimension 2 cross 2. So the first one is this one. The second one is this one that has been highlighted in green. And the cost associated with both of them is 7 units. So let's write 7 over here. The next one is this one highlighted in yellow. So the cost associated for this dimension is 3 units. So let's write 3 over here. And the last one is this one. So the cost associated with this log of wood happens to be of 2 units as highlighted just now. So the total sum of money that gets generated is 7 plus 7 is 14, 14 plus 2 is 17, 17 plus 2 is 19. And in the end, we have another log of wood of dimension 1, 1, which is of course 0 units because you can't sell it in the market. Now comes the question, how can we solve this question up? So we will be using the dynamic programming approach. We will be going in the bottom up fashion, and for each log of wood that exists for each dimension that exists in this log of wood, we will be calculating the maximum money that can be generated for it. We will be going in the bottom up fashion. So the first dimension that we are considering is 1 cross 1 out of the entire log of wood. And if you sell this one in the market, what do you get? You get 0 units. So let's proceed ahead. The next one is of dimension 1 cross 2. So if you sell this entire log in the market, what do you get? You get 0 units. So let's proceed ahead. For size 1 cross 3, if you sell this entire log of wood in the market, how many units would you get? You get 0 units. Let's proceed ahead. The next one is of dimension 1 cross 4. And if you carefully see, then this is a sellable dimension. So let's go back and see the sellable dimensions. Here it is again 1 cross 4. The cost or that you will earn out of selling this log of wood is of 2 units. So let's fill it up over here. So after selling this entire log of wood, you will get 2 units of money. Let's proceed ahead. The next dimension that we have is 1 cross 5. And let's see in how many ways this entire dimension can be cut out. So the first one is this one. So we divided it over here. So what is a new dimension that gets generated? It gets generated as 1 cross 1. And the rest of it is 1 cross 4. And we have already calculated the cost associated with 1 cross 1 and 1 cross 4. What is that cost? For 1 cross 1 it is 0. For 1 cross 4 it is 2 units. So for the entire log of dimension 1 cross 5, the cost associated turns out to be 2 units as per this possibility. What could be the other possibility? The other possibility could be something on those lines. Let's divide the log of wood over here. So one dimension that gets generated is 1 cross 2. The other dimension that gets generated is 1 cross 3. And you yourself observed that for both these dimensions, the cost associated was 0 and 0. So in the other possibility, you are not getting any money. We will be choosing the maximum one out, which is 2. So the answer for this particular dimension turns out to be 1 cross 5. And if you proceed ahead and uncheck for the next possibility, again the dimension is the same. It is 1 cross 3 and the other one is 1 cross 2. So we have already calculated it in the past. The previous one was 1 cross 2 and 1 cross 3. Here it is just swapped. So we will not reiterate it. We will stop it over here itself. Let's proceed ahead. The next dimension that we are interested is this one, which is 2 cross 1. And if you carefully observe from the sellable dimensions that we had, the cost associated is 3 units. So let's quickly go ahead and write the cost associated for this particular log of wood, which is 3. So let's write 3 over here. Let's proceed ahead. The next dimension that we are going to consider is this one, which is of size 2 into 2. So again you will see that this is a sellable dimension and the cost associated with it is 7 units. So the one possibility of dividing this entire log of wood is to sell it upfront and you will get 7 units of money out of it. The other way out is to divide it like this. So the first dimension is 2 into 1, the other dimension is again 2 into 1. So in totality, how much money you will be making? 3 plus 3, which is 6. So out of 7 and 6, which one is the greater one? 7 is the greater one, so we'll keep 7 over here. Let's proceed ahead. So the next one that we have is of dimension 2 into 3. So what we are going to do, let's start the division process. So we will go first in the vertical direction, then we will go in the horizontal direction. And let's divide it over here. So the first dimension that gets generated is 2 into 1. So 2 into 1 gets generated. What is the cost associated for it? The cost associated is 3 units. The other dimension that gets generated is 2 into 2. So for 2 into 2, how much cost have we calculated in the past? It is 7. So for 3 plus 7, what does it give you? It gives you 10. So the first possibility of answer is 10. The first dimension is this one. It costs you 3 units. And the second dimension is this one. It costs you 7 units. And let's proceed ahead. Let's try and divide it not at this junction, but let's divide it over this particular junction. Again, the cost associated with this would turn out to be 7 units and the cost associated for this dimension would turn out to be 3 units. So this is the second possibility that I have written over here. Are there more possibilities? The answer is yes. So instead of dividing it in the vertical direction, let's go horizontal this time. So the first dimension is this one, which is 1 into 3. And the second dimension is again this one, which is 1 into 3. So from the previous calculations, we know for 1 into 3, the cost is 0 units. So this is 0, this is again 0. So 0 plus 0 is 0. So the third possibility is 0. So out of these 3 possibilities, which one are you going to choose? You will choose the one that gives you the maximum result. It turns out to be 10. As a result of which, for this particular dimension, the answer is 10. Let's proceed ahead. Now the dimension has increased to 2 into 4. So let's go step by step. Let's divide it over here first. And the first dimension that we have is 2 into 1. And for this, the cost would turn out to be 3 units. For the next dimension, it is 2 into 3. So for 2 into 3, we have just calculated the answer. What is the answer? It is 10. So let's add 10 plus 3, it gives you 13. So the first possibility of answer turns out to be 13. Let's proceed ahead and let's make the division at some other end. So what this time we are going to divide it over here. The dimension that gets generated is 2 into 2. So for 2 into 2, the cost is 7 units. And again, the other dimension that gets generated is also of size 2 into 2. So for 2 into 2, again, the cost is 7 units. So 7 plus 7 gives you 14. So this is the second possibility of answer. Is there any other possibility of answer? The answer is yes. So instead of going in the vertical division way, we will go in the horizontal division way, something on these lines. So the cost associated with this particular dimension is 2 units. The size is 1 into 4. And from the previous calculations that we did, we can see that for 1 into 4, the cost comes out to be 2 units. So let's reuse the pre-computed values And here you will see we have two such logs of same dimension, 1 into 4, and the total cost earned after selling these two logs would be of 4 units. So out of these three possibilities, what is the maximum one? 14 is the maximum one, therefore it becomes the answer. Let's proceed ahead. The next one that we have is of dimension 2 into 1, 2, 3, 5. 2 into 5. So let's start the division over here, and here the dimension turns out to be 2 into 1. The cost will turn out to be 3, and for this one that I'm just highlighting right now, the dimension is 2 into 5. For 2 into 4. For 2 into 4, the cost that we calculated is 14. So 14 plus 3 gives you 17. So the first possibility of answer is this one. Let's proceed ahead. Instead of making the division over here, let's do the division at some other place. This one. So the dimension generated is 2 into 2. The cost turns out to be 7 units for this. And for this particular dimension, we have already computed the cost. The dimension is 2 into 3. So for 2 into 3, the cost is 10 units. So 10 plus 7 gives you 17. So the second possibility of answer is 17. Let's proceed ahead. Again we will go for the vertical division, and you will see that the dimension generated is already computed. It is 2 into 3, which is 10, and the next is the cost is 10, and the next dimension that gets generated is 2 into 2. The cost is 7 units. So again it's going to be 17 itself. Let's proceed ahead. Instead of going in the vertical way, we will go in the horizontal way. And let me just change the color of pen. Let's take yellow, and let's divide it something like this. We have already computed the cost associated by selling the log of dimension 1 into 5, and it turns out to be 2 units. So the other possibility of answer is 2 plus 2, which is 4. So out of these three values, which one we will take? We'll take the maximum one, which is 17. So 17 value gets set over here for this particular dimension. Let's proceed ahead, and next one is this one that we are going to consider. So the size turns out to be 3 into 1, and as you can see that it's not a sellable size, therefore we are going to divide it over here. For 1 cross 1, the cost associated is 0. For 2 cross 1, the cost associated is 3 units. So 3 plus 0 gives you 3, therefore one possibility of answer is 3. Let's talk about the other possibility of answer. Instead of making the division over here, let's make the division over here. So the first size is 2 into 1, the cost associated is 3 units. The other size is 1 cross 1. The maximum sellable cost for this size is 0. So 3 plus 0 is 3. Therefore the answer for this particular size turns out to be 3 units. Let's proceed ahead. The next dimension that we will look out for is 3 into 2. So what we are going to do, let's divide it vertically first. So let's make the division over here, and we are aware that for the dimension 3 into 1, the cost associated was 3, and as you can see, two such dimensions are generated. So the one possibility of answer is 3 plus 3, which is 6. Let's go for the horizontal division way, and let's divide it over here. For this particular size that I have just highlighted, the cost associated is 0 units. For this particular log that I have just highlighted, the cost associated is 7 units. So 0 plus 7 gives you 7. So this is another possibility of answer. And instead of making the division over here, we could have made the division over here as well at the next boundary. Again, the cost for selling this particular log of dimension 2 cross 2 turns out to be 7, and for this one it is 0. So 7 plus 0 is 7. And the maximum one out of these three possibilities turns out to be 7, therefore the answer becomes 7. Let's proceed ahead. Here the dimension is 3 into 3. So what we will do first, we will go for the vertical cutting, and then we will go for the horizontal cutting. So let's divide it over here. For this particular size that I have just highlighted, this one, the cost associated is 3 units. For this one that I am just highlighting right now, the cost associated is 7. So 3 plus 7 gives you 10. So the first possibility of answer is 10. Let's proceed ahead. Instead of making the division over here, let's make the division over here. Again, it will turn out to be 7 plus 3. The values are just getting reversed, because for selling the dimension 3 into 2, the cost is 7 units. For selling the dimension 3 into 1, the cost is 3 units. So 7 plus 3 gives you 10. Instead of making the vertical divisions, let's shoot for dividing it in a horizontal fashion. So the first one that I'll consider is this one. It's of dimension 2 into 3. For 2 into 3, the cost associated is 10 units, and the rest of the log that gets generated is 1 into 3. The cost associated is 0 units. So 0 plus 10 gives you 10. So out of these three possibilities, the maximum one turns out to be 10, and the answer gets updated to 10 for this particular dimension. Let's proceed ahead. The next dimension that we are interested in is 3 cross 4. Let's make the division over here, and if we'll divide it over here, this dimension is of size 3 into 1. The cost associated happens to be 3, and the other dimension that gets generated is 3 into 3. The cost associated is 10. So one possibility of answer is 3 plus 10, which is 13. Let's shoot for finding out more possibilities, and this time I'm gonna make the division at this particular entry. The size that gets generated is 3 into 2. For 3 into 2, the cost is 7 units, and the other size that gets generated is of dimension 3 into 2. So the cost is again 7 units. So 7 plus 7 gives you 14. So the other possibility of answer is 14. Instead of going for the vertical division, let's go for the horizontal division, and let's consider that we are dividing it over here. The dimension that gets generated is 1 into 4. So for 1 into 4, the cost associated is 2, and the other dimension that gets generated is 2 into 4. The cost associated is 14. So 2 plus 14 gives you 16. So the other possibility of answer is 16. Let's proceed ahead. Instead of making the division over here, let's make the division over here. So the dimensions are just getting swapped. The answer corresponding to this possibility is 14 plus 2. The maximum one out of these four is 16. So the answer becomes 16. Now comes the last case. Here the dimension that we are considering is 3 into 5. So let's make the cut over here. The dimension that gets generated is 3 into 1, and the other dimension that gets generated is 3 into 4. So for this particular log, the cost associated is 3 units. For this particular log, we have just calculated the cost to be 16 units. So 3 plus 16 gives you 19. One possibility of answer is 19. Instead of making the division over here, let's make the division over here. So for this particular log, the cost associated is 7 units, and for the remaining one, which I'm just highlighting, the cost associated is 10 units. So 10 plus 7 gives you 17. So the other possibility is 17 in nature. Now instead of going in the vertical way, let's go for the horizontal way, and let's consider this grid. The dimension is 1 into 5. So for 1 into 5, the cost associated is 2, and the remaining log that is generated is 2 into 5. The cost associated is 17. So the total sum turns out to be 19, and out of these three possibilities, the maximum one is 19, hence the answer becomes 19. Obviously there are more possibilities, but those will be overlapping or already calculated. It's just the permutation of these same possibilities, so you can try those up by yourself. So the next one would be 17,2, and the other one could be 10,7. Similarly 16 plus 3, 16,3. So these all can be generated by you guys as well. You can visualize it, and the maximum one you will yourself see turns out to be 19, which turns out to be the answer. With this, we have successfully iterated over the input test case, and you yourself see how we use the pre-computed values of using dynamic programming to actually derive the final solution. And let's quickly walk through the coding section and conclude it up. Here I've created a DP array of dimension m plus 1, n plus 1, and I iterate through the prices array. I check the x coordinate, extract the y coordinate, and I extract the selling cost. I set dp of x comma y at selling cost. Then I iterate over two loops, I equals to 1, I is less than equal to m. Let's write it in this fashion, it's more understandable. We are starting from I equals to 1 going up till I equals to m, j equals to 1 going up till j equals to n. First of all, we are making vertical divisions, and we start another loop, k equals to 0, k is less than I, and what do? We compare dp of I comma j with dp of I comma j. We expect the maximum value to be pulled out, comma dp of I minus 1 j plus dp of k comma j. So this is an important equation, and if you go carefully see, this is the same thing that I have done in the presentation as well. And once we have explored all the possibilities of vertical division, let's shoot for the horizontal division. So again I have written the same kind of a loop, k equals to 0, k is less than equal to j, k plus plus, and again we'll select the maximum one out of there. Here you will see that the equation is almost the same, just I and j are getting swapped because we are going for the horizontal division instead of vertical ones. Once I'm done with this, I simply return the value that is stored at dp of m cross n. So let's try this out. Accepted. The time complexity of this approach is order of m cross n into n, because we are considering all possibilities of division and vertical division, and similarly order of m cross n into m. The space complexity is order of m into n. With this, let's wrap up today's session. I hope you enjoyed it. If you did, then please don't forget to like, share and subscribe to the channel. Thanks for being it. Have a great day ahead and stay tuned for more updates from Coding Decoded.